The IFT-5 mission, SpaceX's fifth test flight of Starship and Super Heavy on October 13, 2024, showcased the company's unmatched engineering prowess by catching the Super Heavy booster for the first time. And since then, SpaceX has hit impressive milestones, even when all the last three flights 6, 7 and 8 have only been a partial success. The company has pressed on and is preparing for the next launch, while competitors like CES, Roscosmos, ULA, ISRO and NASA struggle to keep pace. And by the end of the year, these entities had performed a total of 79 rocket launches combined in the year of 2024. SpaceX alone conducted 137 orbital launches in 2024, launching a rocket every third day on average. This figure is a testament to the rapidly growing possible monopoly of SpaceX and should be enough to understand it. But we will go further and we will see how this monopoly is absurdly overwhelming to many of its competitors. We will see how this monopoly came to be and how it's not just about technological superiority, but also about opportunity, politics, and an ongoing war. We will see if there is any possibility of someone challenging this supremacy. Today we delve into two specific cases that underscore SpaceX's unshakable dominance. First, the paradoxical reliance of many satellite internet companies such as OneWeb on their own competitor, and ISRO's GSAT-N2 mission. OneWeb, one of Starlink's major competitors in the satellite internet market, tells a fascinating tale. Founded 2 years before Starlink in 2012, OneWeb aimed to revolutionize global connectivity by launching its constellation of satellites. Satellite constellations are vast networks of small satellites working together to provide global internet coverage. Unlike traditional ground-based infrastructure which relies on fiber optics or cell towers, these satellites beam connectivity directly from space to user devices on the ground. This method bypasses the need for costly terrestrial infrastructure, especially in the remote or underdeveloped regions. Low Earth orbit satellites, like those used by Starlink and OneWeb, today offer much lower latency compared to older geostationary satellites, and because of this, rapid, reliable internet access has become possible virtually everywhere on Earth. But satellites have limited operational lifespans, and the ones in low Earth orbit need continual replacement to maintain a seamless coverage, making access to dependable launch vehicles absolutely critical. Basically, frequent and reliable rocket launches are essential to build and maintain these constellations. On 27 February 2019, OneWeb successfully launched the first 6 of its satellites from Soyuz Launch Complex in Sainte-Marie, French Guiana, using a Russian Soyuz STB rocket. The first 13 launches of OneWeb were done on the Russian-origin Soyuz and Soyuz STB rockets. The last launch from a Russian rocket was on 10 February 2022, just 14 days before the beginning of Russia-Ukraine conflict. OneWeb and many other small satellite companies had to naturally change their launch partners under the geopolitical pressure and to provide any possible scrutiny for trading with Russia. Out of their subsequent launches, 2 have been on ISRO's LMV-3 and 6 were aboard Falcon 9, SpaceX's workhorse rocket. This obviously was surprising because SpaceX's subsidiary Starlink is a direct competitor to OneWeb. And this is not only true for OneWeb but also for many other satellite internet companies such as Viasat, SES and Telstar, who had to give up on Soyuz and used Falcon 9 to launch their satellites, or is planning to do so in the near future. Perhaps the most ironic case is that of Amazon's Project Kuiper, a satellite internet initiative under Amazon. Kuiper intended to diversify its launch providers using rockets like Atlas V and Vulcan, but it has also booked multiple Falcon 9 flights to launch its satellites and kickstart its constellation deployment. The development of this dynamic was quite intriguing and ironic because Jeff Bezos' company Blue Origin is considered a potential future competitor to SpaceX. Essentially, the story of these satellite internet companies tell how SpaceX's competitors have to depend on their own rival to stay in the business. India's GSAT mission further illustrates SpaceX's supremacy. The GSAT series, designed for telecommunication and broadband applications, represent India's attempt at satellite infrastructure expansion. One notable example is GSAT N2, which was originally planned to be launched aboard GSLV Mark III or Ariane 5. However, the satellite's final weight was 4.7 tons, and it became clear that GSLV Mark III, with its limited payload capacity, would not be able to handle the mission. This led ISRO to seek alternatives, and with Ariane 5 retired and Russian Soyuz options limited, SpaceX emerged as the ideal launch partner. The GSAT N2 mission was successfully launched on 19 February 2024 aboard a Falcon 9 from Cape Canaveral Space Force Station.
GSAT N2 payload deploy confirmed.
There was some visible reluctance on ISRO's part admitting the involvement of SpaceX. The GSAT N2 launch, despite being planned under ISRO's umbrella, was not openly highlighted in any of the official statements. ISRO's commercial arm NSIL made an announcement without mentioning SpaceX in the tweet, and the mention only being once in the press release. This reluctance to openly acknowledge SpaceX reflected the underlying discomfort, as ISRO would have preferred to use a domestic or traditional launch partner for such an important mission. This launch highlights how ISRO and other global players increasingly rely on SpaceX despite not wanting to, further cementing its dominance in the satellite internet launch market. So why is this so? Why does SpaceX maintain this domination? This domination where no other company is able to come anywhere close to the number of launches of SpaceX. And mind you, the reason is not what you think. SpaceX's Falcon 9 rocket has maintained an astonishing launch cadence, averaging one launch every third day in 2024, with launch costs of Falcon 9 mission standing at approximately $67 million, significantly lower than ULA's Atlas V and $110 million. The economic advantage is evident, and sure, everyone knows the reusability of SpaceX's rockets is a major reason, but there are some other hidden reasons, and in reality a lot more impactful causes that make SpaceX dominate. Now, one thing you might have noticed is that NASA in the entirety of 2024 made no orbital launches, none whatsoever. This wasn't due to any technological shortfall or operational setback, but rather a deliberate strategic choice. NASA, the most historically accomplished space agency, has shifted gears. After decades of building and launching rockets, the agency now prioritizes its true mission: to explore the cosmos and pursue the frontiers of scientific discovery. Rocket engineering, of course, remains a critical part, but it's not the entirety of it. It was in the pursuit of this reorientation that NASA launched the COTS Commercial Orbital Transportation Services program in 2006. The aim was clear: to nurture a competitive private spaceflight industry capable of delivering routine launches and to retire the costly and aging space shuttle.
And we're here to discuss the successful completion of NASA's Commercial Orbital Transportation Services, or COTS, initiative. Through COTS, two U.S. companies, NASA partners SpaceX and Orbital Sciences, developed new spacecraft and rockets capable of resupplying the International Space Station with cargo launch right here on U.S. soil.
Orbital's COTS system will be capable of delivering all types of cargo to the International Space Station, and a planned demonstration flight is scheduled for late 2010.
COTS provided $396 million in funding that enabled SpaceX to develop the Falcon 9 rocket and Dragon capsule, technologies that redefined affordability and reusability in spaceflight. NASA's investment in SpaceX was successful and led to the creation of a competitive private sector in spaceflight. Today, Falcon 9 and SpaceX are rewarded more and more missions to the space station by NASA. When a company grows to the scale of SpaceX, it becomes absolutely crucial to handle logistics and supply chains. Beyond reusability, SpaceX's control over its supply chain is another critical edge. SpaceX has fortified its supply chains and recently invested $280 million for a semiconductor production facility in Texas to ensure Starlink's hardware remain independent of foreign suppliers. Meanwhile, it has also partnered with British firm Filtronic for RF components and want to move Taiwanese manufacture shifting operations to Vietnam. The newly constructed Gigabay factory in Boca Chica, Texas is expected to ramp up Starship productions to meet an ambitious target of 44 Starship flights by 2028. While SpaceX remains the undisputed leader, a few companies have managed to challenge it in niche areas. Despite the sensationalism of it employed in online content, SpaceX's domination in launch market is not absolute. A notable competitor emerging with remarkable launch cadence and innovative strategies is Firefly Aerospace. Traditionally, planning and executing a rocket launch has been a prolonged and expensive logistical endeavor. However, in landmark development, the industry witnessed a significant leap forward. With just 24 hours notice from United States Space Force, Firefly successfully integrated a payload into its Alpha rocket, finalized its launch profile, rolled the vehicle out on the pad, completed fueling, and executed the launch, far surpassing the previous industry record of 21 days. The accomplishment underscores SpaceX's ambition to successfully secure a competitive niche within the highly saturated orbital launch sector currently led by SpaceX. While SpaceX remains the market leader in total orbital launches, there is still considerable opportunity for companies offering differentiated capabilities. One often overlooked strength is the ability to launch on short notice. Picture this. A private satellite designed to generate a steady stream of income, say $1 million every month, once it's operational in the orbit. Now, if the earliest shared launch opportunity is a full year away, that delay translates into $12 million in missed earnings. In such a case, saving money on a much cheaper delayed ride no longer makes sense. The longer it sits on ground, the more financial losses stack up, making rapid deployment more valuable than a bargain. Additionally, the strategic value of rapid launch capabilities is particularly compelling for military applications. This is precisely why US Space Force contracted Firefly for Victus Nox mission. Although the payload details remain classified, the rationale is clear. In the event that a critical satellite is destroyed, swift replacement is vital. Similarly, if a foreign adversary launches an unidentified satellite or potentially a weapon into orbit, Firefly's Alpha launch vehicle has been engineered with these time-sensitive missions in mind. Through targeted innovation and a clear understanding of operational priorities, Firefly is positioning itself as a formidable player in the future of rapid response orbital access.